Good afternoon, selamat sejahtera. Hope everyone is doing well. Can you hear me?
Can, Doctor, can.
Okay. So today, I will move on to another chapter, which is called Materials Requirement Planning. Okay, in short, MRP. And maybe a little bit of ERP. But the focus is more on MRP and just a little coverage on ERP. Just a reminder, okay, now we are already in week 10 or week 11 of the semester. So it means a lot of test two will be coming, a lot of group project submission, maybe a lot of presentation, and also final exams will be coming soon. Okay, let's look at MRP. Now, in the previous chapter, I talked about inventory management. So I talked about models like OQ, POQ to manage what we call independent demand items. Right, independent demand items. So this topic will be looking at dependent demand items. So we'll be looking at for what we call dependent demand items. And this technique is known as materials requirement planning, or MRP. Maybe I should explain again what is dependent demand and also what is independent demand. I have explained before in the previous chapter. But for the benefit of those who are absent or for those who still do not understand, I will just explain briefly again. So what is a dependent demand item? Dependent demand item is where the demand for that item is dependent or is related to the demand of another item in the inventory. Right? Take for example, you have a car. I just draw a car. Okay, you have a car. Okay, and one of the components of the car could be the wheels or the tire. Okay, now let's look at the car first. In this case, the car is categorized as a independent. The car in this category, in this case, is categorized as an independent demand item. Okay, why? Because the demand of cars does not depend on the demand of other components or other materials in the inventory, such as the tire. Okay, the demand for cars does not depend on the demand of the tires or wheels. The demand of the car only depends on the customer orders. It only depends on the customer demands. So car is known as a independent demand item. And in this case, car is an end item. So normally an end item or final product is what we call an independent demand item. But if you look at wheels or tires, these are components to the car, right? So such components or parts are known as dependent demand items. Okay, why? Because the demand of wheels or tires depends on the demand of the car. Okay, the demand of dependent demand item depends on the demand of another item in the inventory. For example, if I ask how many wheels or tires should we order? So how to answer this? Okay, the answer is it has to depend on how many cars we are producing. Alright, so if you are producing 4 cars, then it means we will need 16 tires. Okay, if you include the spare tires, you will need 20 tires. Right, because one car consists of 4 tires, right? One car has 4 tires, so if you're making 4 cars, you will need either 16 tires or 20 tires, if you include the spare tires. So this is what I'm saying, the demand for tire depends on the demand of the car. So in this case, the tires or the components or the raw materials is what we call dependent demand items. Dependent demand items because their demands depends on the demand of another item. So for establishing schedule for dependent demand items, you can use MRP, Materials Requirement Planning. So this is a common technique for generating a schedule or a plan for dependent demand items. So I hope that is clear. I think I've explained this twice already. Okay, first time is during the inventory management chapter. Now I've explained it again. So what are the benefits of using MRP? These are just some of the benefits. Firstly, it can give a better response to customer orders. So it means better on-time delivery. Means we can deliver the product faster to the customer. Second, faster response to market changes. So for example, if the market changes or if customer order changes, then the company will be able to respond faster and cope with the changes faster. Third, give an improved utilization of facilities and labor. So it means it will give a higher utilization of the machines, equipment, facilities, as well as the operators. And it helps to reduce inventory levels. I've said before in the previous chapter, if you are storing too many inventory, then the holding cost of the inventory will increase. So if you reduce inventory levels down the holding cost and right. So in order for us to do MRP, materials requirement planning, you need to understand these 5 things. Okay, these 5 things provides the input information needed for us to perform the materials requirement planning. So we must understand these 5 items clearly. So the first item is what we call master production schedule. Now, this schedule is actually a schedule generated based on the aggregate production plan. If you remember, in the previous chapters, I already talked about the aggregate production planning, right? So the outcome of the aggregate production planning, if we break it down further, we will get the master production schedule. Second item is what we call bill of material. Okay, later I will show you what is the bill of material. Third is inventory availability. So it means how many inventories are available or the quantities of inventory available when we are doing the scheduling. So in other words, it's the amount of inventory on hand. So that is the meaning of the third item. Fourth item is called purchase orders outstanding, or some textbook call it outstanding purchase orders. Okay, what does it mean? It means that these are orders that we have made or purchase that we have paid, but we have not received the order yet. Okay, the order will come in the future. So for example, you have orders on raw material inventory. Okay, you have even make the payment. Okay, you have promised. Okay, the supplier has promised you. Okay, but you have not received the order yet. The order will receive in the future. So that is purchase order outstanding, or sometimes it's also known as schedule receipt. And the fifth item is lead time. I think I already explained what is lead time in the previous chapter. So let me go into detail one by one. What is master production schedule? What is bill of material, and so forth? Because you really have to understand these 3 things. Sorry, these 5 things. These 5 things will be used later in generating the materials requirement planning. Okay, let's explain more on the first item, which is master production schedule. So what is a master production schedule, or MPS? Basically, it specifies what is to be made and when to make it. Okay, of course, because this is a schedule, right? So the schedule have to show what is to be produced, in fact, the quantity of production, and also when to produce the items. And MPS must be done in accordance with the aggregate production planning. So this is what I said just now. Master production scheduling is established based on the information obtained from the aggregate production planning. And as usual, to do master production scheduling, we need inputs from financial plans, customer demand, capacity planning, from engineering, from the supplier, and so forth. And what are the other information of MPS? Okay, this one is important. MPS is established in terms of specific products. So MPS is something specific that we establish for specific products. In contrast, if you look at aggregate production planning, aggregate production planning is something more general. Okay, usually it is done for all the products together, and usually it only shows the total quantity to be produced for all the products together. So aggregate production planning is general, it's not specific, but MPS has to be specific. And the MPS is quite often fixed or frozen in the near term, okay, part of the plan. Okay, what does that mean? It means that MPS normally cannot be changed. Okay, changes are not allowed if we are just about to execute the schedule. Okay, for example, we are 1 or 2 weeks away or 1 or 2 days away from executing the schedule, then changes will not be allowed. It will be fixed or frozen. Okay, but let's say we are still a few months away from executing the schedule, then probably changes can be allowed. And next, MPS is a rolling schedule. What is the meaning of rolling schedule? It means that MPS needs to be done continuously. Okay, it's something rolling means it has to be done continuously, and that schedule has to be uh, done on a regular basis or on a continuous basis. That's the meaning. And please understand this, master production schedule is actually a statement of what is to be produced and when to produce. It is not a forecast of demand. Forecast of demand is totally different. MPS is a statement, it's a schedule of what to be produced, the quantity of production, and when to produce it. Right, now, this diagram I think I have shown several times. Okay, it's just to make you understand again. This is the overall chart on showing where does aggregate production plan fits in, where does master production schedule fits in, where does material requirement fits in, and where does short-term scheduling fits in. Right, so if you look at this overall chart in PPC, in production planning and control, or in any manufacturing company, one of the first things they would do is forecasting of customer demand. Okay, they must know their customer demand first. At the same time, they must plan their capacity. They must do capacity planning. Sometimes they will look at their financial standing or cash flow. Okay, once this three item is done, then they will start to do their aggregate production planning. And to do aggregate production planning, we need inputs from the sales and operation planning team. We need inputs from the supply chain management team, from procurement team, from human resource management team, and so forth. Now, understand, so once the aggregate production planning is done, then the next step is we can generate what we call the master production schedule. So this is what I said just now, master production schedule is generated based on the information from aggregate production planning. And master production scheduling will give the input, will provide the input to companies to do materials requirement planning. So this is a flow to follow. So now I'm talking about master production scheduling because I need you to understand what is this before I can talk about material requirement planning. So master production scheduling provide the information or the input for companies to do material requirement planning. And once you are done with the material requirement planning, then company will go into short-term scheduling. Okay, so short-term scheduling I already covered in the previous chapter. Short-term scheduling. This is where we talk about Johnson rule, if you remember, all the dispatching rule, like first come, first serve, shortest processing time, earliest due date. So those are short-term scheduling. So example of master production scheduling. I think I've already shown this also last time in one of the chapters. So look at this, this part here. This part is the aggregate production planning. So this aggregate production planning is something general. Okay, it shows the total quantity to be produced for all the products together. Okay, for example, this aggregate production planning is showing the total production quantity for amplifiers, for all kinds of amplifiers. And aggregate production planning, if you remember, is done on a quarterly basis or on a monthly basis because it is a midterm type of planning. Okay, so January production quantity is 1,005, February 1,002. So this is aggregate production planning. Huh? Now, this aggregate production planning can actually be broken up into more details. You can make it more specific into what we call a master production schedule. Right? So if we break up the aggregate production planning into weeks, for example, then we will have 4 weeks. Week 1, week 2, week 3, week 4, week 5, until week 8. And we can also further break up the amplifiers into very specific type of amplifiers. Okay, for example, look at here. Now the MPS includes very specific type of model or amplifiers, which is 240 watt amplifier, 150 watt amplifier, and so forth. Okay, and now it shows the specific quantity to be produced every week for each of the specific type of product. So this is master production schedule. So I hope you understand. Now, if we total up this, you will get back 1,005. Because this information is obtained from aggregate production planning. And if we total up this, we will get back 1,002. So this is another example of a master production schedule in the service sector. This is for a restaurant. It's a master production schedule for Chef John's Buffalo chicken mac and cheese. So I think the restaurant is what, Chef John Buffalo. Okay, I'm not sure, but I think the name of the restaurant is Chef John Buffalo. Do we have Chef John Buffalo in Malaysia or Indonesia? I know we have Papa John's, but do we have Chef John Buffalo? Anyone knows? No one knows. Okay, anyway, so Isa say no. Okay, no, we don't have Chef John Buffalo. So this is the production quantity for their food, their product, which is called chicken mac and cheese. Okay, anyone knows what is chicken mac and cheese? I don't think it's the burger. It's not the Big Mac burger, but I think it's the what? It's the macaroni. I think mac is the short form for macaroni. So I think it's chicken macaroni with cheese. Okay, if you ask me lah, that's my understanding. Isa say mac and cheese. Yeah, mac and cheese, but the mac is not the burger mac, it's the macaroni. So if you look at this is an MPS lah. Okay, for producing the macaroni and cheese. So it is now very specific in days, day 6, 7, 8 until 14 and so on. And this is the quantity that needs to be produced every day. So simple things like this are known as master production schedule. Right. So that's the first thing that you understand, master production schedule. So what is the second thing? Second thing is bill of material, and then I will talk about inventory availability, outstanding purchase order, and lead time. Okay, let's go to bill of material. Right, bill of material actually is a list of components, ingredients, materials, parts, sub-assemblies, okay, needed to make a final product. That's the meaning of bills of material. It is a list of all the components or subcomponents or parts or materials or ingredients needed to make a final product. So bill of material normally provides what we call a product structure. So a product structure will look something like this. Okay, later I'll explain this product structure. And it says what? Items above a given level are called parents, and items below a given level are called children. Okay, I'll explain this. So imagine you have a product. So this product is given in the textbook. Is the speaker. It's the speaker set or the speaker kits. So this speaker set is known as awesome. It's an awesome speaker set. So for simplicity, we just abbreviate it using A, yeah? So it's a product A, yeah? Now, this is the bill of material. So you look at the bill of material, it shows all components or subcomponents needed to make the final product, which is A, which is product A, which is the speaker. Now, a product at an above level or at the above level is called parent. So in this case, I can say A is the parent and B and C are the children. Okay, so in other words, B and C are needed to make A, or in other words, I can say A consists of B and C. Okay, I think you understand. And same thing, I can say that E and F are the children of C, but C are actually the parents of E and F. Okay, so in other words, C is a parent as well as the children, because C is a children of A, but then C is also a parent of E and F. Understand? So this is what I'm trying to interpret from here. The items above given level are called parents, items below given level are called children. Okay, as simple as that. So again, if you look at here, F is actually the parent of G and D, then G and D are the children of F. Okay, so a bill of material has different levels, but it has to start with level 0. Always remember that. It doesn't start with level 1, it starts with level 0 and then go to 1, 2, 3, and so forth. So the final product always has to be written at level 0. So level 0 is for the final product. And level 1 will consist of all the components that make up the items in level 0. In other words, level 1 will contain all the components that make up their parents, which is A. Okay, so similarly, level 2 will consist all the sub-components, sub-components that will make up their respective parents. Okay, which are C and D lah. And level 3 will consist of all the sub-components, or in other words, all the children, which are needed to make up the parents in level 2. Okay, so I hope that is understandable. Another thing you need to understand is you see numbers here, right? Numbers beside each of the component or subcomponent or sub-subcomponent. So what does this number mean? It means, for example, B bracket 2. So it means what? It means 2 units of B are needed to make 1 unit of A. Okay, just remember that. Same thing, you see a number in bracket here, 3. So what it means is that it means 3 units of C are needed to make 1 unit of A. Okay, let's go to level 2. For E, you see a number here too. Okay, can anyone tell me what do you understand by this number 2 here? Okay, anyone? What is the meaning of this number 2 besides the alphabet E?
There are 2 units needed to form B.
Okay, it's correct, but I try to make it more accurately. It means 2 units of E are needed to make 1 unit of B. Just remember that it doesn't mean 2 units of E are needed to make 2 units of B. Okay, got it? It means 2 units of E are needed to make 1 unit of B. It doesn't mean 2 units of E are needed to make 2 units of B. Okay, so always remember that. Same thing, we have 2 here. So basically it means 2 units of F are needed to make 1 unit of C. Not 3 unit of C. Please remember that. Okay, and so forth. You have number here, number here, number here. Okay, so let me give you a simple challenge to solve. If let's say 50, yeah? 50 units of the final product, which is the speaker A, yeah? Are needed. Okay. Okay, how many B components will be needed to make 50 units of A? Okay, anyone can just type in the chat. This is a very simple question. Okay, I see a lot of answer 100. So correct, because it's 2 times 50. So it's 100. Okay, okay, let's continue. For C, how many C are needed to make 50 units of A? 150. Okay, correct, because it's 3 times 150. It will give us 150. Okay, okay, now let's move on to something I think which is slightly more complicated. D. Now look at the bill of material carefully. D is here. You have D here on the left side, and you also have D here on the right side. So D is required to make B so that B can then be used to make A. And then on the right side here, D is needed to make F, and F is needed to make C, and finally C is used to make A. So anyone can give me the answer? How many D will be required in order to produce 50 units of A? Oh, okay. There are some answers already. Okay, Kyrie is very fast. He said 800. I think it's correct. 800. Okay, why 800? Why 800? Anyone can explain?
It's 2 times number of B and then plus with the 2 times number of F.
Okay. Okay, so let me continue. I just type here for D. Okay, remember we need 50 units of A. So for D, we need to use 2 times 2 and then times 50, on the left side, right? 2 times 2 times 50. Then on the right side, it will be equals to 2 times 2 times 3 times 50. Okay, so I think if you work this out, you will get 800, right? 600 plus 200, yes, 800. Okay, so the answer is correct. What about E? Okay, I think it's the same concept. To know how many units of E are needed to make A, so you look at the left side, you have E here, you have E here, and you also have E here on the right side. So on the left side, the number of units required is 2 times 2 times 50, and then on the right side will be 2 times 3 times 50. So this will give us 500, correct? 200 plus 300, so 500. Okay, correct. And F, how many number of F is needed to make 50 units of A? Anyone? 300. Right, correct, 300. And how many number of D is needed to make 50 units of, not D, G, sorry. How many number of G is needed to make 50 units of A?
Also 300.
Okay, correct. Okay, so I hope you understand. I already explained to you. So for F, you need 300. Okay, and for G also, we will need 300. So keep that understanding because later we will need this information to perform the materials requirement planning. Okay, I think the answers are given here. So for those who still cannot understand, spend some time to study this and hopefully you can understand. Okay, in bill of material, it says that item is coded at the lowest level at which it occurs. What is the meaning of that? Item is coded at the lowest level at which it occurs. Okay, if you look at D, item D. D actually can be written here, right? So why does it have to be written at level 3 rather than level 2? Because of this, because D is also needed to make F. And because F is already in level 2, then D has to be in level 3. And because of that, over here, we cannot write D in level 2. We can only write D in level 3. This is the meaning. Item is coded at the lowest level that it appears. I hope you understand. Item is coded at the lowest level at which it occurs. And bill of materials are processed one level at a time. So this is what I've done just now. Okay, I start with A and then ask you to calculate B and C, and then I go to E, then D, F, and G. So you have to process it at one level at a time. Right, the next thing that you understand is this inventory availability. Okay, inventory availability means the amount of inventory which is available at the time that you are making the schedule. So in other words, it's the on-hand inventory, how much inventory is available on hand. So I don't know whether you understand on hand or not. On hand means not on my hand, not on human hand. It means on hand. It means how much inventory is available when it is needed. That is the meaning of on hand. So to perform MRP, we must have accurate inventory records to show how many inventories are currently on hand. So accurate inventory records are absolutely required for MRP. In fact, MRP systems require more than 99% accuracy. Okay, 99% accuracy of the amount of inventory available. So this is accurate inventory records. Okay, I think it's easier. I can move to the next one. Okay, next one is purchase order outstanding. Sometimes it's known as outstanding purchase orders. So as I said, this basically means that orders that we have placed, orders that we have made, or purchase that we have even paid. Okay, but the order has not arrived, and the order will arrive sometime in the future. Okay, so outstanding purchase orders must accurately reflect the quantities to be received and when you will receive it in the future. And very often it is also known as scheduled receipt. So scheduled receipt basically means receipt which is scheduled to be received in the future. So that is scheduled receipts. So scheduled receipt in short is just outstanding purchase orders. So please remember these two terms are sometimes used interchangeably, but don't get confused. Basically they mean the same thing. And the fifth things that you have to understand is lead time. Okay, lead time for components. So what is lead time? I've explained before in the inventory management chapter. So basically lead time is the time required either to purchase or to produce an item. So different definitions here. It depends on whether your component is being purchased from a supplier or your component is being produced in-house. Okay, both are possible options, right? Some companies will produce their component in-house, but some companies will prefer to order or purchase their component from another supplier. So if the component is being produced in-house, so it means the company is making the components themselves. So in that case, lead time will mean it is the sum of the moving time, which is the transportation time, plus setup time, plus assembly time, or production time. So if you add up all this, it becomes the lead time for components which is being produced or made in-house. Okay, so it's just the sum, lead time is just the summation of the transportation time plus setup time plus assembly time plus production time. And for components which is purchased from suppliers, then the lead time definition is different. So for purchase items, lead time is actually the time between the recognition of a need and when it is available for production. So it means lead time for purchase item is the time between placing an order and receiving an order. Okay, so that time gap between placing an order and finally receiving the order, it is known as the lead time. So two definitions that you have to understand. It depends on whether the component is being produced in-house or being purchased from a supplier. And these are the lead time given for the 7 components mentioned earlier. Now, please be familiar with this bill of material because later I will use this when doing the MRP. We'll be using the same product, which is for this speaker set. We use back the same bill of material and the same lead time will be used. So the lead times are given here. We have 7 components, right? Yeah, including the final product. So we have 7 items here. Now, if we integrate the lead time with the bill of material, or in other words, if we put in the lead time into the bill of material and turn it 90 degrees clockwise, we will change it into a time phase product structure, just like this. Okay, so this is called a time phase product structure, and all the blue color line are actually the lead time. Okay, 1 week, 2 week, 3 weeks, 1 week, 1 week. These are the lead time. Okay, how to interpret this? I think you can interpret this easily, right? For example, A has to be completed in week 8. Okay, and therefore arrive. Oh, sorry. Okay, A has to be completed in week 8, so it means that the production of A must start in week 7. Okay, because the lead time is 1 week. So similarly, for B, okay, week 7, the lead time for making B is 2 weeks. So if we work backwards 2 weeks, okay, you will be here, this point here. So at this point here, it means that D and E must be completed at this point so that we can make B, so that we can start to make B. Okay, because B will need 2 weeks as a lead time to be completed. Okay, so similarly, if D has to be completed in week 5 here, then it means we have to start the production of D in week 4 because the lead time for purchasing D or making D is 1 week. Okay, so I think it's easy to understand. So in short, if we need A to be completed in week 8, then it means that we have to start the production of G in week 1. Okay, and we have to start the production of D in week 2, production of F in week 3, and so forth. Right, so to summarize what I've discussed just now, this is the main thing that I've discussed just now. So I'm trying to explain to you this material requirement planning. This is the main topic in this chapter. So to do material requirement planning, we need information or input from 5 different items. Okay, we need input from master production schedule. We need inputs from bill of material. We also must know the lead time. We also must know the inventory available or the inventory on hand, as well as any schedule receipt or outstanding purchase orders. So these are the 5 items that I discussed just now. So these 5 items serve as the input. It provides the input information to perform material requirement planning. So once we have that, then we can do the material requirement planning for each of the specific component or product. Okay? Okay, so if you understand, then maybe I can proceed. I can proceed. We still have some time. All these are the steps that I will explain now. So rather than reading point by point, it's better for me to explain to you using the real example. Okay, so this is the real example how to do material requirement planning. So as I said just now, to do the material requirement planning, we need 5 things. Okay, so the question is, it says what? Based on master production scheduling, 50 units of A must be completed in week 8. Perform the material requirement planning for all the components. That is the question. So in order for us to perform the MRP, we need inputs information from the 5 things that I mentioned just now. Okay, so the first thing is we must know the MPS. Okay, so in this case, the MPS information is given. It says 50 units of A must be completed in week 8. So this is the input information obtained from MPS. Second information we need is the bill of material. So this is the bill of material. It's the same bill of material that you have seen just now. It's exactly the same. Third piece of information we need is the lead time. Lead time. So lead time is, as I said, is given as given before. Lead time. Okay, this lead time here. So we're using this lead time here. And what else we need? We must also know the quantity of inventory on hand, quantity of inventory available. So the quantity of inventory on hand is given here. It's given here. So these are the inventory available on hand at the time that we are making the materials requirement planning. So for item A, we have 10 units on hand. For B, we have 15 units on hand. Okay, now why do we have it on hand? Because probably it is something left over from previous production. For example, extra quantity that previous week has produced. So it's being carried forward. So for this month, we have it on hand. That's the meaning. That's the meaning of inventory on hand. And the last piece of information we need to know is there any outstanding purchase orders? Or in other words, scheduled receipts. So for this question, assume there is no scheduled receipt yet. Okay, assume there is no outstanding purchase order at the moment. So to do the MRP, so you have to work with what we call MRP worksheets. So this is the MRP worksheets. Okay, I'm not sure whether exam will give you this worksheet or not. If we don't give you, then you will have to be very familiar with the format. So this is the MRP worksheets. Okay, let me explain what you need to fill up in this worksheet. First is you have to fill up the name of the items or item identification. So let's start with product A first, which is the final product. So for A, so we just fill up A lah. Okay, and second column is the level code. So if you look at the bill of material, A appears at level 0, correct? So we fill up 0. Okay, that is the second column. Third column is you have to fill up, is there any additional units that is needed? Is there any additional units that have been allocated for A? So in this case, assume no. So we assume no, so we put dash. Fourth column is about safety stock. Remember, I've explained safety stock in the previous chapter. Okay, in this case, there is no safety stock, so assume no safety stock, so put a dash. Next column is what is the current on-hand inventory available, okay, for this component or for this item or for this product. So the question gives 10, 10 units, so you fill up 10 here. So it means currently we have 10 units of A available when we are making the schedule. Okay, and then lead time, as I said, is given just now. I've shown the table already. So the lead time for making A is 1 week. So we fill up 1. Okay, and finally, in the last column here, it says the lot size. What is the lot size technique that we are using? So the lot size technique that we are using is called lot for lot. Okay, what is lot for lot? Lot for lot means we produce exactly what is required, or we order exactly what is required. That is lot for lot. Right? So it means if we require this size of the lot, then we order this size of the lot, or we produce this size of the lot. So that is the meaning of lot for lot. And on the right side, you have this table. So 8 weeks. Why? Because it says 50 units of A must be completed in week 8, right? So therefore we have 8 weeks. So it has to be completed in week 8, 50 units. So we fill up 50 here. Okay, easy, right? Fill up 50 here. And as I said, there is no schedule received at the moment. No information is given in the question, so we assume there is no outstanding purchase order, so no schedule received. Okay, what about projected on hand? Projected on hand means what is the on hand inventory that we have? What is the quantity? We have 10, right? So therefore, we have to fill up 10. Okay, now, as I said before, this is the inventory that we have on hand when we are trying to make the schedule. So it means we already have it before we start to make any of the components, right? So therefore, you write it somewhere before week 1, 10, means it's already available, okay, beforehand. So this 10 will be carried forward, week 1 to week 2 to week 3 until week 8, because it's only week 8 that we need 50 units of A, right? So this on-hand inventory will be carried forward until week 8. Okay, understand? Now, the next row is what we call net requirements. Now, net requirements is only 40. Okay, so you fill up 40. Okay, why 40? Because we need 50 units of A in week 8, but then we already have 10 units of A in the inventory. So 50 minus 10 will give us 40. You understand? Okay, gross requirement is different from net requirement. Gross means gross. Net means what is actually required. Gross requirement is normally obtained from master production schedule or aggregate production planning. So in this case, gross requirement is 50. We need 50 units of A in week 8. But we already have 10 units of A in the inventory on hand. Okay, probably which is a leftover from previous production or some kind of stock that we are keeping in the inventory. So if we already have 10 units of A, so what we need actually is only 40, 50 minus 10, 40. So net requirement is 40. Okay, and the next two rows are important to understand. This is called plan order receipts and plan order release. So if we need 40 units of A in week 8, so it means we must complete 40 units of A in week 8. Or in other words, we must receive the order of 40 units of A in week 8. This is what we call plan order receipt.
Victor, it's lagging. We can't hear you. Can you please repeat?
You cannot hear me. Oh, I've been talking for so long.
No,
So
no, it's lagging. You just starting explaining the planet order receipts.
okay, which part the voice is not clear? I think it's the internet problem. Which part is not clear?
For both parts, you have said it's the most essential part, planet order receipts and the planet order releases.
Oh, okay. So you heard what I said regarding gross requirement, projected on hand net requirements. You heard that?
Yes, please.
Okay. So net requirements we require 40. Net requirement is what we actually require. Okay, now the last two row is what we call plan order receipt and plan order release. So if we need 40 units of A in week 8, then it means that we must receive that order from our supplier on week 8. Correct? So this is what we call plan order receipt. So therefore we write 40 here. If you are ordering from the supplier, so if you are ordering from the supplier, because we need 40 units of A in week 8, so we must receive that order from the supplier in week 8. Okay, or if you are making it in-house, then it means that we must complete the production of 40 units of A in week 8. So therefore we write 40 here. Huh? We write 40 here. Now you know that the lead time for A is 1 week. Okay, so if we push back 1 week, it will become week 7. And for plan order release, we can write 40 here. Okay, so it means what? It means 1 week before week 8, at week 7, we should already place the order. We should already make the order, or we should already release the order so that it will arrive in week 8. Understand, right? Because lead time is 1 week, so the plan order releases is 40 units at week 7. Okay, or in other words, you can say that we should start the production of 40 units of A in week 7. Okay, so that after 1 week, which is a lead time, it will get completed in week 8. Okay, so understand this whole table? Okay, I hope you understand. Huh? All right, so that is for A. Yeah? So we are done for A. Okay, then we have to go down the bill of material, level by level, and do the material requirement planning for B, C, D, E, and so forth. Okay, let's look at B. Yeah? Let's look at B first. Now, B is needed to make A. Yeah? Exactly 2 units. 2 units of B are needed to make A. So if we need 40 units of A, yeah, in week 7, so it means what? It means 80 units of B will be required in week 7. Correct? 40 times 2. Each unit of A requires 2 units of B. So if we need 40 units of A, then it means we need 80 units of B. We need 40 units of A in week 7. So it means 80 units of B has to be completed in week 7 so that we can start the production of A. Understand? We need to start the production of A, or we need to start order A in week 7. So in order for that, we will need 80 units of B to be completed in week 7. So this is where we get 80, yeah? 40 times 2, 80. And again, there is no schedule receipt, as I said, so no schedule receipt for item B. Projected on-hand inventory for B, currently we have 15. So you fill up 15 here, and then you just carry forward week 1, week 2, week 3, week 4 until week 7. Okay, at week 7, you stop. Okay, you don't have to fill up week 8 because week 8 has nothing. Okay, then you can calculate the net requirements. The net requirements is just 80 minus 15, you get 65. Right, because you require 80 as the gross requirement, but you already have 15 units of B. So it means actually you only need to produce 65. 80 minus 15 give us 60. And then you bring down 65, you bring it down, and you write it under plan order receipt. Okay, because 65 units of B has to be received or has to be completed in week 7. Okay, and you know the lead time for ordering B or for producing B is 2 weeks. So you work backwards 2 weeks. 1, 2. So we mean week 5, you should already release the order. So you write 65 here. Okay, now releasing the order means starting the production. As I said, there are 2 different concepts. Either we make the product in-house or we order from the supplier. So if we say release the order, it means make the order, okay, or place the order, or start the production. That's the meaning of order release. And order receipt means we receive the order or the production is completed. Okay. Okay, I think it's 5 o'clock. Maybe we stop here first. Wednesday, I will continue with item C. Okay, item D, item E, F, G, and so forth. Okay, basically it's not something difficult. You just have to understand the bill of material. You have to understand the concept of inventory on hand, schedule receipt. Okay, because later this thing will get complicated when we have schedule receipt, when we have allocated quantity here, and probably if you have safety stock here, then the calculation will become more complicated. Okay, any questions so far? If not, I think I should stop here. It's already about 5 p.m. Huh?